Hi, everybody. My name is Dominic Della Sala. I'm the chief scientist at Wild Heritage, which is a project of the Earth Island Institute based in Berkeley, California. I'm speaking to you from my home office in Talent, Oregon, as one of the survivors of the Alameda September fire, but I'm not here today to talk to you about wildfire. I'm here to talk to you about a nature-based climate solution that involves the protection of primary forest and the proforestation component of that. And I'll define what both of those are in the presentation. So thank you for having me today, and I hope you enjoy this 15-minute talk. Well, there's a lot of chatter about nature-based climate solutions, and it's in the literature, it's in the media, and you're all at your summit to discuss potential solutions. And I'm here to just lay out some of the basic science around nature-based climate solutions. One of the groundbreaking studies that came out in 2017 was able to quantify nature-based climate solutions, looking at a series of pathways of all different ecosystems. And their conclusion was, if we went with a nature-based climate solution using natural ecosystems to store carbon, we would achieve about 1/3 or so of the mitigation benefits to keep the climate from overheating above the 1.5 degrees centigrade threshold. And that's really critical if we're going to forestall major climate disruptions coming in as soon as a decade or so. And so what is fundamental to this is an understanding of the role that forests play as a terrestrial carbon sink and their long-term storage capacity. And the best places to do that are in primary forests, and I'll define what those are in a moment, and also to allow the degraded forests sufficient time to recover their diminished carbon stores from past logging. That's called proforestation. And alternatively, storing carbon in wood products is just delaying the obvious, that there are going to be emissions over time, both at the point of logging, which is where you get most of the emissions, and then the decay process of the wood products over time. The logging, transport, manufacturing all uses fossil fuels. And so those are emitting carbon to the atmosphere. So how can we reduce or minimize or not allow those emissions to go up into the atmosphere? So I'll say a few words on that as well. So what are primary forests? Now, much of my career has focused on these places, both in the tropics and in the temperate system, and more recently in the boreal, the forest of the northern latitudes, like in Canada and Russia. And these are forests where all the processes and native species are working in place. And there's no visible signs of industrial logging or any other industrial activities. Now, many of them have native people living in them, particularly in the tropics. So there is human activity. It's just not on an industrial scale. And it's where we see natural recovery processes at play. So they're not just old growth forests. It could be an old growth forest that went through a recent insect infestation or a burn. It's still primary because it hasn't been logged, and it still maintains both its climate and biodiversity benefits, as we will see. So primary forests, here are some of the benefits of these places. They're really nature's wellspring of biodiversity. In fact, 2/3 of the Earth's terrestrial biodiversity is in forest. Most of that is in the tropics, and most of it is in primary forest, the unlogged forest. Forests globally represent about 30% of the total terrestrial cover, the land cover, and they store massive amounts of carbon. You can see 1 gigaton of carbon is roughly twice the mass of humanity, and forests store 400 gigatons of carbon. So they play a central role as the planet's lungs. The mature forests in North America, particularly, are important as the lungs of our region, and they contain thousands of imperiled species that are highly concentrated in these unlogged forests. And whenever I talk about carbon in my presentation or at your summit, please consider that there is a difference between sequestration and storage. Sequestration is the process of photosynthesis that uses light energy, water, and basically the cycle of photosynthesis to produce carbon in excess. That's the plant's food. And then that excess carbon is stored in the trees, the soils, and the forest biomass over time. So it's important to consider both the process of sequestration and the long-term storage in those forests. For instance, if you've taken a hike in a mature forest and you look around those giant trees, those are big sticks of carbon that have been accumulating carbon for centuries in places. And it's not just the mature forest, but recently burned forests also are incredibly biodiverse and carbon rich. And most of that carbon that happened during the fire stays in that forest. About 90% of it, only about 10% of it is released during the process of a fire event. So it still has a lot of carbon left. And if you protect that carbon, it comes with a basket of ecosystem benefits like clean water, pollination, all kinds of traditional uses, and biodiversity that is captured by protecting the carbon in those carbon dense places. So here's a map of the carbon storage of all the world's biomes, and by different color codes. You can see the light green are the boreal forests of the northern latitudes, which contain enormous amounts of carbon stocks. Then the darker green, the temperate regions, and finally the very dark green are the tropics. And so when we look at maps like this, it's both important to look at carbon storage based on total area of the forest, in which case the tropics and the boreal really come out as globally significant. But then there's the density of carbon. How much carbon is present per acre? And that's where places like the Pacific coastal temperate rainforest in North America really stand out on a global scale. So both area of the forest and density of carbon need to be considered when we look at a snapshot of the globe's biomes, carbon-based ecosystems. So back to primary forests, these are really the carbon powerhouses. They store much more carbon than the readily logged forest, and it's the largest trees in those forests. Again, look at those giant redwoods. They're big sticks of carbon that's sitting out on that land base for centuries, storing carbon. And they represent only a small portion of the total forest biomass, but they accumulate over 50% of the total carbon in that forest in just the largest trees alone. We're not even talking soils, which are another significant sink of carbon. And as mentioned, the temperate rainforests of North America are some of the most carbon-dense forests in the world. Places like the Tongass rainforest and the Pacific coastal rainforest, as we will see later in the slides, are globally significant because of their carbon density. So what about the extent of primary forests? Where are they and how much is left? Well, back in 2014, I co-authored this paper in Conservation Letters that used the information at the time on primary forest. You can see where the US stands. It's roughly number 4 in the world in total primary forest, behind Brazil, Russia, and Canada. And then you can see how the rest of the world trails off in terms of the remaining 1/3 of the world's forests that are still considered primary, that have no evidence of industrial activity. And those forests are going away quickly. So this slide shows in different color schemes, different decade periods, with 1990 to 2000 being the lightest blue, and then the most recent one being the white color. And you can see that in all cases, except for a couple of noted examples, and we'll talk about that in a second, but in all cases, the world is losing primary forests. Now, there's been a slight uptick in North and Central America and Europe, That's possibly due to more countries reporting to the forest assessment database on their primary forest remaining. But by and large, even though the decline has decelerated, it's still happening on a global scale as we enter more and more of these incredibly biodiverse, carbon dense regions. And this is a snapshot, a recent picture from the Global Forest Watch data set of the World Resources Institute in red, showing areas of forest loss. And the only problem with this picture is it depicts fire as a forest loss. I don't see wildfire as a loss. It's just a change in the successional stage of the forest. But a lot of this also is due to logging. And in fact, when you tease out the logging impact, it's equivalent to a loss of forest on a global scale of 18 European soccer fields every minute of every day. That's occurring around the globe. That's the rate of deforestation, put at a scale that perhaps we can all understand because we've all been on soccer fields, and that's a phenomenal rate of loss. And here's what it looks like in two regions of the world. So I've done some work in the Amazon with some colleagues that are working with the Kaipau people that are faced with incursions on their land. And you can see that blob in the middle, that dark green blob is what's left of the traditional territories that have been encroached by slash and burn agriculture. This is deforestation occurring in Amazonia. On the other side of the screen is closer to my home. I did a flyover of some of the coastal region of Oregon. You can see in this case, this is forest degradation. So you'll still get a plantation coming back on that landscape, but it lacks the carbon and biodiversity values. And this is a highly fragmented system that is losing biodiversity and carbon, and it is important to stop this leakage. So here are the choices that we face roughly in general. We could keep carbon in the forest by changing our ways, mostly our forestry practices, protecting the primary forest and allowing forests to continue to sequester for centuries, or we could send it to the atmosphere, which is what happens with whenever a forest is logged. And even though replanting or natural forest seeding comes back and refills those areas in North America, they function as sequestration dead zones for at least a decade until the trees come back and start sequestering carbon, and they never recapture the debt that has been emitted to the atmosphere, as we will see in the next slide. So forestry in general, the way it is practiced industrially, is a top carbon emitter. Whenever an old forest is logged, about 80% of the carbon is returned to the atmosphere. Only about 19% is processed or retained in short-lived wood products. And those wood products do not rival the storage capacity of an old growth tree, which can live for centuries. On average, depending on whether you're a paper product, you're in the landfill in a year, or if you're in a building, you're in a landfill within several decades, you're not hanging on to that carbon for centuries. So it's a delayed emission. As already mentioned, the young forests that come back are CO2 emitters for at least the first decade or so. They function as dead zones. That emitted carbon takes centuries to recover. We don't have centuries in a climate emergency. And logging large landscapes emits more carbon dioxide than forest fires, contrary to what a lot of people believe. But this has been repeated. The studies that have come out over several regions have shown the same thing over and over again. It's not the wildfires that are big emissions, it's logging at industrial landscape scales. We hear a lot about biomass burning, and a number of studies are now showing that it's an inefficient way to capture energy, and it releases more emissions than coal. And so that's not a solution by any means. And basically, anytime we take carbon out of the forest, it's not staying in that forest, but eventually it winds up into the atmosphere. So these are not carbon neutral, they're not capturing the carbon debt, and they're not climate smart practices. So we got to look at it on a relative basis that anytime we remove a stick of carbon from the forest, that carbon mostly winds up in the atmosphere. So here are some pathways to consider for plugging the gaps. First of all, let's look at US national forests. They're really good as a carbon sink, and they sequester about 12% of the US annual emissions. That's an equivalence calculation. And so they play a vital role as nature-based climate solutions if they are responsibly managed. And to do that, we have to protect the stocks. On a global basis, primary forests are the best way to do that because they have most of the carbon. We've got to end deforestation and forest degradation. There was a UN New York declaration that was signed over a decade ago to end deforestation and forest degradation. We have to allow the forests that have already been degraded enough time to recapture their degraded stocks by allowing them to mature. Talked about proforestation. And then there's all the other pathways that I kind of grouped together. Replant the area with native species, increase the rotation length in harvested landscapes, afforestation of fallow agricultural areas. Those also contribute, but less so than the two previous pathways. And there's an opportunity now in front of us with the Biden administration to develop a proposal that I'll be talking about for strategic carbon reserves to allow the US to lead in its re-entry into the Paris Climate Agreement and its nationally determined commitments to that agreement. We've got the Glasgow Climate Summit coming up. We've got the administration's interest in 30 by 30, protecting 30% of land and water by 2030. All of these are opportunities for a solution. So here's the first pathway. If we end deforestation, there's a huge emission savings. Now, I don't have the number for North America yet, but it's going to be significant if we can put our primary forest into a natural carbon reserve strategically located. We will contribute to emissions reductions on a substantial basis. We're in the process of figuring that number out now. And although it's more difficult to measure, degradation emissions are also important. They range from 5 to 132% of the total forestry emissions globally. And every time we emit carbon in the atmosphere, it has a social cost of carbon in terms of climate impacts. And that's going to approach about 2% of the US GDP annually by the century end if we don't start saving our forests today and reduce our emissions in our energy sector. So ending forest degradation in the US is the most cost-effective mitigation strategy, considering the delayed cost and the realized cost of social cost of carbon. So here's what a preliminary proposal looks like for a natural strategic carbon reserve design. This is based on some work I did about a decade ago. A number of us are in the process of modifying these maps, updating them, and filling in some more of the regions with their carbon champions. But at the time we came up with a number, we pitched it to the Obama administration at the end of their administration to put 50 million plus acres into a natural strategic carbon reserve on federal lands. And that would be the equivalent of 7 times the US emissions. So you can see that definitely would move the needle on carbon and climate security if we were able to protect those forests in a strategic carbon reserve design. And here's what it looks like for individual national forests by their carbon density. These are the top 25 showing areas unprotected in the light shading and protected in the dark shading. I have to change the Tongass because of the Trump administration's rollback of the roadless protections. But by and large, the Tongass is the national champion. It stores about 10% of US emissions. And so it's very significant as a climate champion and needs to be the leader in pushing through a strategic carbon reserve system for US federal lands. The second pathway, regrowing the stock or proforestation, has very significant global benefits. About 120 gigatons of carbon could be saved by proforestation, which is equivalent to 12 years of current emissions. Now, you hear a lot about planting 1 trillion trees by 2050. That has significant benefits, but much less than the benefit of proforestation in terms of the gigatons of carbon stored. It also it's delayed because planting 1 trillion trees is going to take decades before those areas start to accumulate carbon on a significant basis. You start to get into competition for land space and other uses. There's a lot of interest in planting exotic species, and that's going to have biodiversity impacts, as well as converting biodiverse grasslands and shrublands to planted trees that all have biodiversity impacts. So the bottom line here is that regrowing the stock is much more natural and has a lot more climate benefits than planting 1 trillion trees. So you might be thinking, well, okay, that's all great, but where's our wood going to come from? And so this is based on an analysis of just using existing tree plantations worldwide represents about 3% of the total forest area. And by different time periods, 2005 being the baseline, this is what the world's fiber supply has been from plantations. And here's what it's projected over 2 scenarios to meet demand in the coming decade. We do nothing in the dark blue, we meet demand. If we increase silvicultural practices to crank out more on the same land base, we can crank out more fiber without having to convert primary forest. We could also switch to alternative fibers that can save additional gigatons of carbon. In the US, for example, I've got some data on that as well if folks are interested. Wood is important, but it's not the only place we can get our fiber. So here's my last 2 concluding slides. We're in a climate emergency here. Thousands of scientists have called on governments to really ramp up protection of primary forest and other natural landscapes and to reduce our emissions. Not only are we reaching a dangerous tipping point on the climate, but we are contributing to the pandemics that we see today. When we disturb natural areas, we release zoonotic disease organisms that are affecting the world population in many ways. So this is important to our own health. We've talked about how forestry is a top carbon emitter. 11% of the emissions globally come from forest degradation and deforestation. In the United States, forestry is tops as a carbon polluter. And basically what we need to do is keep the fossilized carbon in the ground and the atmospheric carbon in the forest. Primary forests are the best way to do that. We talked about the proposal for a national strategic carbon reserve by protecting the stocks and allowing the degraded areas time to recover as a means for re-entering the Paris Agreement, hitting the 30 by 30 targets. And while storing some of the carbon can happen in wood products, it's not a substitute for protecting forests. So here's my concluding slide now. You know, Elon Musk puts out these pledges periodically for new prize to capture carbon. And some of us have been thinking about just submitting the forestry information. And the solutions that we could talk about here are, you know, let's finish up the mapping and then protect the high carbon stocks and the proforestation areas. That's currently underway. We've got a lot more that needs to be done to achieve that. But in North America, we're making progress on this and need to get this in front of the administration. All of the other pathways are important, but less so, like lengthening harvest rotations, afforestation, reforestation, ecologically based restoration. They all contribute, but every time you take carbon out of or a tree out of the forest, you're removing carbon. So it's important to have a life cycle analysis that is current, is scientifically defensible, and can allow landowners to choose between alternatives to minimize their impact, to be more responsible. I don't think there's a such thing as climate smart forestry because we remove carbon from the forest every time we take it out, but perhaps we can get to climate responsible forestry and responsible procurement practices, which I hope you have sufficient time to digest this presentation and factor it into your discussion at the summit. Thanks again, and I'm available for any follow-up offline. Appreciate being here today.